Normal distribution. There are many situations where a continuous random variable is most likely to be close to its average value, and values further away from the average become increasingly unlikely. There are many such situations. For example, people's height, adults' height. So very short or very high people are few. The height of the majority of people are close to the average height. Another example, people's weight, adults' weight. So very light or very heavy people are few. The weight of the majority of people are close to the average weight. There are many such situations. Many such situations can be modeled using the normal distribution. We use the expression x follows normal distribution mu this guy square. We use this expression to express that a continuous random variable follows a normal distribution. Here, x represents the continuous random variable, and this symbol means follows, and this guy means the normal distribution. And mu is the mean of the continuous random variable. And this guy is the variance of the continuous random variable. And the probability density function of a normal distribution is like this. Fx is the probability density function. Fx is like this, 2 pi, this, and 1 top, multiply e to the power negative 2, this square. Here is x minus mu square. This function is complicated, so it is impossible to integrate this function in the conventional way. So we have to use calculator to find the integration of this function. So to find the probability of a continuous random variable that follows the normal distribution, we have to use calculator. Then let's check the graph of the probability density function. It's like this. Here is the mean of the continuous random variable. And the graph of the probability density function is symmetry about its mean. From the graph, we can also see that the farther the value is from its mean, the more unlikely that the random variable be that value. And next, let's talk about this score. This score is a formula. It's like this. Z equals x minus mu over this guy. Here. This guy's square is the variance of the continuous random variable that follows the normal distribution. This is the variance. And this guy alone is the standard deviation of the random variable that follows the normal distribution. And from this formula, we can infer that z is the number of standard deviations that x is away from the mean. Now, what's the usefulness of this formula? In fact, with this formula, If there is a continuous random variable that follows normal distribution, we can use this formula to create a new random variable from this old random variable. The new random variable is like this: z follows normal distribution. This normal distribution is special. Its mean is 0 and its variance is 1. This distribution is called standard normal distribution. So why we do this? In fact, this is very useful. We will talk about its usefulness later. And also, let's see, from x less than or equal to small x, we can get x minus mu less than or equal to small x minus mu. And we can get this one, x minus mu less than or equal to small x minus mu. And we use capital letter Z to represent this guy. Then we get Z less than or equal to x minus mu. This one. So from this guy, we infer this guy. So we can infer that the probability that x less than or equal to small x equals the probability that big Z less than or equal to x minus mu.